Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening to Dr. Khairul Anas bin Muhammad Rizali. My name is Abdullah Khan. My matric number is 191381. I'm doing dynamic course and I'm going to explain about uh, kinematics rigid body. So the table of contents for the presentation is introduction, problem statement, which is description and the problem solution and conclusion. So what is the kinetics of rigid body? Formally, it's defined as a collection of the particles with the property that distance between the particles remains unchanged during the motion of the body, unlike approximation of the body as a particle, and this is never strictly true. All bodies differ as they move. The problem is that the figure is placed over a block of the wood, 60 millimeter, and of the thicknesses, and facilitates extraction of the nail. If the force is 400 Newton and perpendicular to the hammer, and it's required extract the nail and find the force on the nail and the force at the point A while the nail starts to remove in the position shown. So assuming that the weight of the hammer can be neglected, which means we are going to ignore it and compare to the other sources that there is enough friction in the prevent the hammer from the sliding. In the order to extract the nail without bending, and the hammer must be used in the way that can make it vertical and upward forces Fn and over the nail. So the reactions of the force will be force that nail extracts on the hammer with the same magnitude Fn. But the pointing of downward as shown will in the free body diagram, which is this one. So that will be also have been ignored and contain the forces in the A separated into the two certain component Fx and Fy. So for the problem here, this is the free body diagram which I have drawn. And if the nail extract without making the hammer acceleration, so we are going to find here produce the moment of A and some moments of that is. So for the first one, for to find Fn, okay, so the Fn here 0.06 multiplied by Fn minus 0.4 multiplied by 400, we are going to get 2667 Newton, and then the sum of the horizontal component forces must be equal to 0 also. So we are going to find the Fx, which is 400 cosine 20 minus Fx. So the Fx is 375 Newton, and then also the vertical component, we are going to find it by 400 sine 20 plus Fy, which we already found here, 2500 uh, 2530.2 Newton. So the conclusion, the kinematics of the rigid body in the general motion space will be studied, and the main objective will be learn how the velocity acceleration particle of the body of the rigid body related to the translational and rotational parts of the motion of its motion.